We have all met someone who breaks our typical understanding of intelligence. You watch an expert mechanic effortlessly tear down and rebuild a complex engine, only to see them struggle to navigate a simple hello at a party. On the flip side, you might know a student who barely scraped by in algebra, yet they bypassed academia entirely to build a thriving logistics company using purely practical, real-world street smarts. These anomalies highlight a massive blind spot in how we measure human potential. For over a century, society has leaned on IQ as a definitive label, often using a single numerical score to categorize individuals as smart or not smart. Behind closed doors, psychologists have spent decades debating how the brain actually functions. They are trying to determine if human intellect is powered by one central, unified mental engine, or if it operates as a collection of entirely independent skills. The answer changes how we design our schools, who we hire, and how we assign value to human potential. The concept of a single mental engine traces back to Charles Spearman's two-factor theory. He proposed that human intellect runs on a single overarching core baseline of mental energy, known as general intelligence, or G. This diagram illustrates how Spearman's theory predicts performance. He argued that a high score in spatial reasoning automatically guarantees high performance in verbal and math tests, because the same underlying G factor fuels all three domains. He did acknowledge that humans have unique talents, like drawing or playing an instrument, but he classified these as specific factors, or S, minor traits that only influence individual tasks rather than overall intellectual power. This document identifies the Cattell-Horn-Carroll theory, breaking general intelligence into hierarchical layers. First is fluid intelligence, a student's raw processing power to solve unfamiliar puzzles. Then, crystallized intelligence, an older adult winning trivia using a vast, accumulated lifetime of knowledge. While these models recognize different layers of memory and speed, they both still view intelligence as a centralized, singular system. The move toward a multimodal view was led by Gardner. He rejected the idea of a single IQ score, introducing a theory that the human brain operates on at least 8 autonomous modalities of intelligence. Looking at this table, Gardner maps traditional skills like logical-mathematical alongside musical and bodily kinesthetic skills. This creates an asymmetrical profile, where a student might struggle with geometry, yet display genius-level capability when choreographing a complex dance routine. In this moment, the student synchronizes complex physical movement with musical rhythm, while simultaneously reading and mediating the social friction between their classmates. Robert Sternberg's Triarchic theory moves the debate further by focusing on 3 real-world operational domains. This page defines Sternberg's 3 categories: analytical, book smarts; creative, imagination smarts; and practical, street smarts. This creates an academic asymmetry. A student might earn straight A's analyzing papers, but struggle to invent an original thesis or network. These theories suggest that we should evaluate humans based on a diverse set of independent toolkits, rather than a single processing speed limit. This debate between a singular mental power and a multimodal system informs how we structure our standardized assessments and professional entrance exams. If our schools and workplaces only measure analytical abilities, we overlook significant portions of human capability. This diagram shows a standard, singular bell curve chart fracturing and expanding into a multi-axis web. It illustrates how we can map capabilities like spatial navigation, physical mastery, and practical street smarts that traditional testing ignores. Moving forward with this science requires us to abandon the reductive question, "How smart are you?" Instead, we must ask the much more precise, modern question, "How are you smart?"